part of mathematics in which letters and other general symbols are used to represent numbers and quantities in formulae and equations. Symbols and letters are used in the place of numbers. In this expression, we have A plus B. There could be some numbers involved there. So you can have that, for example, A is maybe 2 or some other value. But here we are representing those numbers by these letters. The first thing we are talking about here is expansion. And they want us to consider this expansion. The first thing we want to consider is A plus B. A plus B squared. A plus B squared. This one means that you have A plus B into A plus B. Because A plus B squared means that you get that thing and you have it twice. That when you have 4 squared, you have 4 times 4. That's why I say that when you have A plus B squared, you have A plus B into A plus B. Now what we are going to do, we are going to get this A and multiply by this whole bracket. And also get this B multiplied by the whole bracket. So this is what you do. You get A multiplied by this thing. This A multiplied by the whole bracket. A plus B. Then you get this B also. And the symbol which is here, the same as the symbol which is there. This one is now A plus B. You multiply like that. And now when you open the brackets here, A times A, that one is A squared. A times B, you get AB. Then plus B times A. Oh, it is BA. But I want to tell you that BA is the same as AB. B times A. You can write that it is equal to AB. Because we prefer to write them in alphabetical order. Actually, it is cool when you write, instead of writing YX, we write it as XY. There is no penalty. There is no penalty you are going to get by writing BA. But I want to write it as AB because at one point of time when I say that you are getting AB plus BA, that it is equal to 2 of AB, somebody will say, that one again. So I want us to write them to be the same, and actually they are the same. So I want to write it like they are the same. I want to write them to be similar to one another because they are indeed similar. So B times A is what we are writing as AB. Then B times B, that one is B squared. When I work out this one further, I have A squared. Then AB times plus AB, that is AB plus AB. I shall have twice of AB. AB is now existing 2 times. I have twice of AB. Then this one is B squared. And that one is supposed to mean that A plus B into squared is equal to A squared plus 2AB plus B squared. Avoid this thing as much as you can. Some students are like A plus B squared is equal to A squared plus B squared. Oh my gosh. This one here is not the same as this one here. I can show it to you. When you have, let us have something we know very clearly, that 4 plus 6 is equal to this one, 4 plus 6. By using body mass, first consider what is in brackets. We are going to get 10 squared. We are going to get 100. However, if you say that 4 plus 6 squared is equal to 4 squared plus 6 squared, we are going to have this one as 16 plus 36, which is equal to 50. Tracing that, which does not check. So here, by using this one as a substitute for the, by substituting this one, by using this one as being equal to that, as being equal to a plus b into squared, you are creating problems. You are getting it wrong. That one is wrong, so avoid it. So the true value, the correct value, is the one we have just got. The one we have just got, which is this one. So it is a squared plus b squared plus 2ab. This expression here is missing out the 2ab part of it, which was supposed to add there. Like here, if I add 2ab, it means that I shall be adding here 2 of this one times that, which is 24, and then times 2, 48, and when I add here 48, I shall be making it to the 100 there. So avoid it. Let me even erase a bit, because when you see it here, you may be tempted to have it stuck in your brains. Don't make it stuck in the brains. It is something wrong. It is terrible. A mathematician writing like that. Oh. We have this one, a minus b squared. We can write this one as a minus b into another a minus b. That's what it means, that you multiply it twice. So you have this a times the whole bracket, a minus b. Then take this minus b times the whole bracket, minus b. That's what we do. You multiply this by this bracket, then minus b times that bracket. That's what we are doing there. So we shall have we now have a times a, that is a squared, a minus, oh, not minus, it is a times b. This one is a minus, so the minus just gets there. Then a times b, that is ab. B times a, it gets back to what I told you. It is ab. It is ba, yes, and ab, ba is the same as ab. Yes, you get ba correct, but ba is the same as ab. And I prefer to use this because it is similar to this, and I shall have to add them later, and to avoid the confusion that may come up later. So I have this one is negative b and negative b. That's why I have a plus b squared. When you have a plus, a minus, and a minus, the final thing will be a plus. This one further comes to, you see that AB minus and AB, you shall have a minus 2 AB, then plus b squared. So around here, shall have that now the identity a minus b squared is equal to a squared minus 2ab plus b squared. That is what you need to know. That identity is going to, it is a very important thing to avoid the scenario. You can avoid this where you say that a minus b squared is equal to a squared minus b squared. Oh man, let me even cancel it. It is not correct, please. It is not correct that way. Then we can move on. We have a plus b into a minus b. Two brackets. One contains a plus b, another one contains a minus b. How can we handle that? It is still just a matter of expanding. We are expanding. Of course, we are expanding by opening the brackets. So we have a plus b, a minus b. This one is equal to, you have the a of the first bracket, the a in the first bracket, and multiply everything in the second bracket. Multiply a by the second bracket, then multiply b by the second bracket. So we have plus b multiplied by the second bracket still. So a multiplies the second bracket and also b multiplies this bracket. So we multiply every term in the first bracket by every term in the second bracket. That's what we are doing. Every term in the first bracket is multiplied by every term in the second bracket. So a multiplies a and b, even b multiplies a and b. That is precisely what we are doing there. So I have a times a, that is a squared, a times b, that is ab, b times a, that is another ab, b times b, there is a plus and a minus, you have a plus b and a minus b. So this one will get us a minus b squared. And when you work out this one, we will cancel that. But I don't prefer to write like that. So this AB, which is minus, will cancel with this AB, which is positive. I remain with a squared minus b squared. And now the identity is this: a squared minus b squared is equal to a plus b into a minus b. We call this the identity for a difference of two squares. A difference of two squares. One bracket plus another bracket minus. This a is there, this b is there. So when you have, for example, when I have 9 minus 4, I can prefer to write this one as 3 squared minus 2 squared. Because 3 squared is a square, then the 2 squared is also a square. And now a minus b is a difference of a and b. And now when I square that, this is a square and that one is also what? A square. So this is one square, another square. So the difference of two squares, square 1, square 2. So the difference means subtraction. So when I have this, I have a difference of two squares. Difference of two squares. So I have this one, it can be written as 3 plus 2 in one bracket, then 3 minus 2 in the other, and I have 5 times 1. This one is 5, this one is 1, and I have 5. It is in concordance with what you have here. 9 minus 4 is 5. But now I've used this formula of the difference of two squares to illustrate the identity we have just acquired here. A minus b squared is equal to that. Difference of two squares. We shall have a good number of examples on that. You shall enhance, you shall understand it better. Then we have expand that. We have nothing to do. We have got to expand it. Let's try to see what we are going to do about it. This one is a plus b into a squared minus ab plus b squared. So still what we do, we shall get this a, get all the terms in the first one, that is the a of the first bracket, multiply by the second bracket. A squared minus ab plus b squared. Then get the b, this b here, multiply by second bracket still. So this one is a squared minus ab plus b squared. There we are. So a, we now multiply a times a squared. It is, let me put it here, a times a squared. This one like a power 1. So I have a power 1 plus 2. We are applying indices. Power 1 plus 2, which is equal to a power 3. Yes. So a times a squared is a power 3. Then minus a times ab. You have two a's. That one is a squared and b. Then a times b squared. That one is a b squared. Then plus again b times a squared. You can ably say that this is b a squared, but I prefer to write it as a squared b. It is the same thing, b a squared b, because I want to create some bit of uniformity in the equation so that you can see which quantities are going to cancel, which quantities are similar. Because it is not easy to tell someone that now that when I have b a squared plus ab squared, we are going to get 2, but we are going to get 2ab squared. I want to have them similar so that you can clearly see which quantities are merging and which quantities are cancelling each other out. So b a squared, let's agree that we are going to write a squared b. Then b times ab, you have b and b, that is b squared. And the symbol plus and minus shall have a minus a b squared. B plus and b plus, then b times b squared, that one is plus b power 3. That is what we have there. Now you see that this a squared b, this one is a squared b, this one a squared b, we'll go with that one. Both of them actually both of them are a squared b. Then this one will go with that one. Because one is positive, one is negative, they will be cancelling each other out. And now from there, if those one was cancelled, I remain with a power 3 plus b power 3. And right now I can write the identity now. A power 3 plus b power 3 is equal to a plus b into a squared minus ab plus b squared. This identity will be useful. It is really something we normally use. When it comes to factorization, you're going to need it because these ones are the factors of this. To get this, you multiply this by that. It is like having that factorize, maybe factorize 6, you get 2 times 3. So these are the factors of 6. Just like these two, this, that are the factors of this. So if it was a question telling you to factorize this could be the answer. These are the factors. You have factorized this bracket times this bracket equal to this. So we call the terms, the expression is in on the right hand side, the factors of this. These ones are the factors of this. We move on to, there's another identity here. We have a minus b into a squared plus ab. This expression can give us another identity. So we shall still do what you have been doing. Get a, multiply the whole bracket. A is the first a in the first bracket, multiply by the second bracket. So that is a squared plus ab plus b squared. Get this b here with its symbol there, and multiply the second bracket, negative b into a squared plus ab plus b squared. And then this one is now you shall have a times a squared, that is a cubed. Then a times ab, this is a times a, that is a squared. And then a times b squared, this is a b squared, minus the minus you have there is the minus you have here is this minus. So minus, you have a minus of b times this is positive. So the anything should be minus. And now I got b times a squared. This one is b a squared. But I told you I prefer to write it as a squared b. So this is a squared b. Then b times ab, that is a b squared. B and b is b squared, then a there is there. From there we have b multiplied by b squared. That one is b power 3. B power 3. The minus, because this one is plus, this one is minus. Plus minus will get us this minus. Positive minus will get us that minus. I want to show the values that are cancelling. First of all, this a squared b will cancel with this a squared b, because both of them are a squared b, and the one is positive and the other is negative. Then this ab squared will cancel with this ab squared, because both of them are ab squared, and one is positive and another is negative. So it's like you're having ab squared minus ab squared, which is 0. A squared b minus a squared b still gets us a 0. And so from there, out of all that chunk, we shall have a power 3 minus b power 3. And it can lead us to the identity that when you have a power 3 minus b power 3, you can have this. That identity is very important, and you're going to be finding it when it comes to factorization. By factorizing, you'll be finding that identity is very, very important. We can now have some examples on factorization, having had the other expansions. The first one is saying that factorize the following expression is, the first one is 3x plus xy. So you have 3x plus xy. You consider there is x here and there. So you pull it out. When x is pulled out, here remain with 3, such that you remain with the value here, which is in such a way that when you multiply again, you get 3x. When you get x times 3, you don't get x3. We don't write mathematics like that. You get 3x. We prefer to write the numbers before the letters. The letters come after the numbers. First write the number followed by the letter. So we are looking for the number which we can multiply out and get 3x. And then here the number which you will multiply this x to get xy is now y. So x times 3x. X times y, xy. So this is now the factorized version of this. So these are the factors of this. That to get 3x plus xy, you get x and multiply by 3 plus y. That is factorized. This one is 22 22pq plus 55qr. They want us to factorize that. So you always look for the common factors that exist in the two terms. There is this term, this term, and then that term. We have two terms in this expression, and the factors that are common there. You realize that 22 is a multiple of 11, and 55 is also a multiple of 11. So there is 11 here and there. This one, you cannot say that 20 because 22 is not a factor of this, but 11 is a factor of this expression, of this term, also this term. So you can pull out 11. And actually realize that there is also a q. There is a q here and there. So you pull out 11q. And when you pull out 11q, here we shall remain with 2p. We look for a value which is in such a way that when you open the brackets back, you get back to the original expression. Like when you have 11q times 2p, the 2 and the 2 will get us the 22, the 2 and the 11 will get us the 22, and the q and the p will get us the pq. Yes. Then around here, since 11q is here we shall remain with 5r. In such a way that when you multiply 5 times 11, that is 55, then r, which is there, then the q, which is here. So this is 11 times 5, 55 qr. So this one is that is the factorization for this particular question. That's the factorized version. Yeah, we can advance. Let us advance. If you had factorized this one completely, we shall have, let me first rewrite it. This one is 10u squared minus 10v squared. I can pull out 10 because 10 is common everywhere. It is here and there. So I shall have 10 into u squared minus v squared. And we shall now recall this identity, that a squared minus b squared is equal to a plus b into a minus b as factors. So the term in the bracket also bears some factors still. So you can further say that this one is equal to 10 into u plus v into u minus v. So I'm writing it for you that u squared minus 10 v squared is equal to 10 into u plus v into u minus v. That is factorizing it. You can see, first pull out the 10, then you remain with what you remain with in the brackets is a difference of two squares. Then you apply that, and the voila, you are there. This is 81 minus 25 w squared. I want to write it like this. 9 squared minus 5 squared w squared. So that you can see that it is really a difference of two squares. I can also write it as 9 squared minus 5w squared, because 5w squared actually is the same as 5 squared w squared, which is exactly that one there. That's what we have. And so we shall now apply the fact that this one is the difference of two squares, and we have 9 plus 5w into 9 minus 5w. You take as if this one is a, that this one is b. A plus b into a minus b. That's what we are having. we're relating that to the fact that a squared minus b squared is equal to a plus b into a minus b. Yeah, that's what we have there. This is another problem on difference of two squares. So we have 16x squared minus 121y squared. You can write this one as 4 squared x squared minus 11 squared y squared. Yes. And you can ably say that this one is 4x squared minus 11y squared. You have 4x squared, so you can take 4x as a and 11y as b. And if this is like a, actually you can take a look at this chunk here as a and look at that as b, and then you relate it with the fact that a squared minus b squared is equal to a plus b into a minus b. So we shall have that this one is now the a 4x plus the b 11y into 4x minus 11y. That is what we have. Difference of the squares. 16 is the same as 4 squared, so you are grouping them square, and then I'm putting them in the bracket to show that I have one thing. 4x is being squared, 11y here, 11y is being squared to get this. So look at this one as a, look at that as b. Yeah, I guess you have got it. Fm plus Fn plus Gm plus Gn. We can group these things, and I think they are already grouped. So there is an F here and there. So we shall have for these two, we shall pull out F. We shall actually, the first thing was to group them. So we have Fm plus Fn in one group, and you have another group Gm plus Gn, such that now here there is F and F. Pull out F, remain with M plus N. When you pull out F, so you remain with N here, so that F times M, Fm, F times N, Fn. Then we have plus, the G is common here, so there is G everywhere. So you have M plus N again. When I pull out G, there is M and then N remaining when G is factorized outside. So we are saying that this one is equal to this, is also equal to that. You should communicate. We are communicating in mathematics. So tell us that this one is equal to this one, which is also equal to that one, and proceed. And this one is equal to, you now realize that what do you do when you have f of a plus ga? What you do, you pull out a and remain with f plus g. So look at m plus n as the a I'm referring to at this point, because you have f times this bracket, then you have g times f times bracket, g times bracket. So we are going to pull out that bracket. Pull out that bracket, m plus n, it is everywhere, it is here and also there. So what we are going to do, mn, when mn is factorized out, this position remain with f. Then when m plus n is factorized out, remain with g there. So we have that this whole chunk here can be factorized into this one here, and indeed if you try to open the brackets here, you'll get back to that one there. That's what we have. Now this one is saying that simplify CD minus CE. For some people who are having smaller screens may not be able to see. Maybe let me first show you. They want us to simplify this CD minus CE over D squared minus E squared. So what we are going to do here, we shall say that this one is equal to CD minus CE divided by, down there we have a difference of two squares, so we have D plus E into D minus E, difference of two squares. Then up, there is a C everywhere, so C into D minus E. I'm factorizing this, the numerator. C is everywhere. I'm factorizing it out, so that I have C times D, CD, C times E, CE. That's what we call factorizing. You pull out something so that when you open the brackets, it gets back at what you had originally. So this is down here, D plus E into D minus E. And now you see that we have some brackets there which can cancel each other out. You see that this bracket and this bracket are the same, and so they can cancel one another. So here we shall remain with up there shall remain with only C, and down here remain with D plus D plus E. This one is the simplified version of that expression there. In an examination, you don't cross like the one I'm crossing with these blue lines. Just write from here and then you go to that one there. It is fine like that. Part B, they are saying that P plus Q, they want us to, it is simplifying still. Simplify, this one is P plus Q over AP plus HQ. This one is the same as P plus Q, and down here there is A everywhere. Factorize it out, remaining with the P plus Q. And after that, you see that there is P plus Q everywhere. If I put this in a bracket, you see that this one is down here. You have P plus Q, such that now this P plus Q up there will cancel with that P plus Q down there. And when you have those ones cancelled, the thing you are going to remain with the 1 over A. That is just 1 over A. And just come to that, just 1 over A. Yes. This is now factorize. Factorize the following expression is. We have got to factorize that. You have G power 3 plus 27. This one, G power 3 plus 27. Remember this, you are going to use this. Remember this expression. A power 3 plus B power 3 was equal to A plus B into A squared minus AB plus B squared. Find a way of having this identity get stuck in your minds. You practice a lot and have this thing. It's an identity. And I think identities are got by, can I say, cramming? Yeah, but sometimes you first cram before the thing can later get stuck in the mind and you understand it after trying hard to memorize it. So try to memorize these identities as much as you can. They are easy to memorize. That when this is plus, the plus here is also the plus there. Then this one is a squared minus ab plus b squared. When it is minus, the minus is here and the rest are plus here. That's what happens. So we are going to use this identity main. Guys, we are using this. Ladies and gentlemen, okay. Ladies and gentlemen, we are using that. This one is the same as g power 3 plus 3 power 3. So that we can now, relating to the other, this identity, you have g, this one is g plus 3 into, it will be g squared minus ab, which is 3g plus 3 squared. So we have that g plus, this is g power 3 plus 27 is the same as g plus 3 into g squared minus 3g plus 9. The 9 is the 3 squared. This one here, this is the factorized version of this. These are the factors. You can get this by multiplying this times this. So we have factorized that. This one is 27x power 3 minus 8, which we can write as 3x. This one is 3 power 3 x power 3 minus 2 power 3. And I want to tell that this one is the same as 3x the whole changa power 3 minus 2 power 3. You can look at it as if you are having this one as if this is A and this is B, and then substitute in this formula that A, actually it is A power 3 minus B power 3 is equal to A minus B, and this is A squared plus AB plus B squared. This is the identity we are going to use. We are going to use this identity. I can now, from here, I'm moving down to our, continue with our question. This is 27x power 3 minus 8 is now equal to, what is our A? It is 3x minus, what is our B? It is 2 into, what is A squared? It is 9x squared. So because the A is 3x, so I have 3x times 3x. That is the A squared, this one here, A squared. So you have 3x times 3x, that is 9x squared. Then plus AB. AB is like you have 3x times 2. So you have this one as 6x. Then plus B squared, which is equal to, B is like the 2. So we have this one as 4. That is, yeah, that's what we have. It is what we have there. We have another expression here. That one is 512. We have 512. which we can have still as 512 minus 27 y power 3 can be written as 8 power 3 minus 3 power 3 y power 3, and this is 8 power 3 minus 3y power 3. And still look at this one as A, look at that as B, and substitute in the equation. So the general formula is A power 3 minus B power 3. I think by the way, the number of times I'm writing these identities, you can grasp them. You can, by the time we are done, you will be able to write them yourself. So this one is A minus B into A squared plus AB plus B squared. So we have that 512 minus 27 y cubed is equal to what is our A? Now A minus B. So you have 8 minus B, which is 3y, into A squared, that is 64 plus AB. AB is you have 8 times 3y. So this one is 24y plus B squared. Our AB is like you have 8 times 3y, that is 24y, the one I've written here. And now plus B squared. B squared is for like a 3y times 3y. So this one is 9y squared. That is what we have there as the answer. Factorizing that. There is more. Man. This one is E power 3 F power 3 plus G power F in the bracket power 3 plus G power 3, and we handle this as if we are having, you take it as if this one is A and this one as B. Yeah, it's like you have A cubed, B cubed. So you know that A cubed plus we know that A cubed plus B cubed is equal to A plus B into A squared minus AB plus B squared. So we shall now able to say that E F power 3 plus G power 3 is equal to, what is like our A is EF plus what is like our B is G into A squared. This is A squared EF, because A, it is like you're having EF, the whole chunk squared, which is E squared F squared, the one I've written here. Then minus AB, this one is E F G, it is like you're having EF times G. Then plus B squared, what is like our F is G, so that is G squared. And so that is exactly what you have. EF plus G into E squared F squared minus EFG plus G squared. That is the factorized version of this expression here. Yes. We shall have more examples in the next video. Welcome. We have some continuation on algebra, and we had some factorizations, and we are still continuing with the factorizations from the identities we learned. We have some more examples here. This one is saying that a power 3 plus b power 3, the one that factorize, and I'm telling that one is the same as factorize out to the m and have a power 3 plus b power 3. And now this is exactly the other identity. This one is a plus b into a squared minus ab plus b squared. That's how you can factorize out. Pull out the m first, then the other one is a cubed plus b cubed, which is an extraction from our identity. There we have been handling it. Two x cubed minus 16y cubed. We can first factorize out the 2. The 2 is everywhere, and we have 2 into x power 3, and I factorize out 2 from there. That remains with this is 8y power 3, and I again have 2 into x power 3 minus 2 power 3 y power 3. Yeah, you can able say like that. Then I have this as 2. I open a square bracket because I want to put something there in brackets, and I have 2y, that is power 3, like that. So the terms in the square brackets, they are in conformity with our identity. If I take this one to be a and this one to be like b, then it is neglected like that. Then we that a cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. So we can relate this and say that now this one is equal to continuing with our expression. This is 2. Then out inside here the a minus b. So we have this minus that. So this is x minus 2y into. Now this a minus b, a squared. That one is x squared minus this is a plus ab. Our a is x, our b is 2y. So we have 2xy. Then plus b squared. Our b is 2y. So we have 2y squared. That is 4y squared. And that is the factorized version of that expression. That's the answer there. (375) p q power 3 minus 3p. Factorize. It is factorizing. Now there is a 3 here, and there this one is divisible by 3, and there is a p here in this term and also there. So what we are going to do is to pull out 3p, because it seems that 3p is everywhere. When I pull out the 3p, this one shall give us 125 q power 3 minus, that is now 1. That's minus 1. And I can write this thing as 3p. Then I have an open bracket here. I have 5q power 3 minus 1. This one is 5. Let me write this. This is 5 2 power 3 then minus 1. Because 5 2, when I have that thing power 3, the same as having 5 power 3 times 2 power 3, and 5 power 3 is 125, then 2 power 3. It is what I've written here, so don't be left out. That's what we have there. This one is 3p. We now relate to identity. We shall need to make use of the identity. It is like this one is A and this is B. Actually, 1 is the same as 1 cubed. So look at that 1 as the B. 1 is the same as 1 cubed. So this one, it is like the identity A cubed minus B cubed, because this one is also 1 cubed. So what I'm going to do is to put there the cube itself. Put there the cube so that people really know that that this one is what? A cube. This one is power 3. Alright, sorry for there's been some inconvenience here. So we get back to, yes, this is it. I told you this one is the same as having 1 power 3, because 1 power 3 is the same as 1 times 1 times 1, which is still equal to 1. And now our identity comes in handy. A power 3 minus B power 3 is A minus B into A squared minus AB plus B squared. This is plus. Yeah, so we have that getting back to our expression, we have that 375. This is P2 power 3 minus 3P is now equal to 3P into, this is 5Q minus 1 into 25Q squared plus 2A. That one is AB. So it is 5Q times 1. So simply we have 5Q. Then plus B squared, that is 1, because B is in the place of 1. 1 is in the place of B, and that is 1 squared, which is still 1. That is the factorized version. 3P plus 5 into 5Q minus 1 times 25Q squared plus 5Q plus 1. That is what we have there. For 128 minus 54t cubed. 128 minus 54t cubed. There is let's pull out 2. 2 is a common factor everywhere. So I shall have, when I pull out 2 there, This one is 64 minus this one is now, if I pull out 2 there, this one is 27 t power 3. The terms in bracket can be written as 64 is the same as 4 power 3, then minus 3 power 3 t power 3. Having that, we shall have this one as 2 into 4 power 3. This one is 4 power 3 minus 3t power 3. Yeah, we have 3t. And relate this one with AB, where our A is now like A is equal to 4 and B is equal to 3t. So we shall have that this is now equal to 2 into, it is supposed to be A minus B. Oh, I'm writing again A minus B. So A is 4 minus B, which is 3t, into, this is A squared, so this is 4 squared plus AB, that is 12t, because we are supposed to have 4 times 3t, AB 3 times 4 times 3t, then plus B squared, which is 3t squared, and we finally have this one as 2 into 4 minus 3t into 16 plus 12t plus 9t squared. That's what we have there. We are using the identity. I think I've written this identity very many times, but I can write it here still. It will not be bad. A power 3 minus B power 3 is A minus B into A squared plus AB plus B squared. So A minus B, A squared, AB, which is this times that, B squared. There, relate what you are given here with the identity and substitute those values there accordingly. We have that. Simplify. They want us to simplify these expressions. Yeah, we have this is A. Oh, yes, I should use a black pen here. This one is A plus B over A power 3 plus B power 3. This is A plus B. Now down here, this is A plus B into A squared minus AB plus B squared. And this is equal to, you can see that there is A plus B up there and A plus B down there. So what you are going to do is to see that this one and that one will cancel. And they remain with the, up there shall remain with only 1 divided by A squared minus AB plus B squared. That is the simplified version of this expression. They want us to simplify this. It is P power 3 minus 8 divided by P squared minus 4. P power 3, you have P power 3 minus 2 power 3 divided by P squared minus 2 squared. So what we are going to do, we are going to express these as these are like the identities. So compare these with the upper one, compare it with a cubed minus b cubed, and look at p as a and 2 as b. So we have the numerator will get us p minus 2 into p squared plus 2p plus 4. This is a minus b into a squared plus 2 plus ab p times 2 plus 4. The 4 here is the b squared. And down here, what you have down here is the difference of two squares, where we have 2p plus 2 and 2p minus 2. And what we have here is the fact that this p will cancel with that. Yeah, there will be some cancelling of some numbers. This one cancelling with that. And so we shall remain with if those one was cancelled, shall remain with the p squared plus 2p plus 4 divided by p plus 2. And that is the simplified version of what we have there. Actually, it looks like yeah, it is like that. Cannot simplify it any further. That's the final thing. Factors of ax squared plus bx plus c. So this one is basically factors of quadratic expressions. Quadratic expressions are those with the term in x in squared, having a square power. So how do we factorize such expressions? You have one term containing x squared, another one with just x, another one with a constant. These are not linear, they are quadratic. So whenever you have an expression in that form, it is in the form a x squared plus bx plus c. What you do, find the two numbers such that their sum is b and their product is ac. B is the coefficient of x and a the coefficient of x squared, c the coefficient of, that is actually the constant term. You get those two numbers such that their sum is that number, not the number in the middle but the coefficient of x, because you never know, somebody may write his expression like this. We shall not just as the number in the middle, so we shall say the coefficient of x. And if an expression is given in this form like this, you have got to rearrange it in this format. You have the x squared first, followed by the x, then the constant term. So for our first example here, we shall have that our sum, we need to find the two numbers so that the sum is 5, because that is the coefficient of x, and the product is equal to 1 times 4, which is equal to 4. And the numbers that can give us those results, the first number is 1 and the other one is 4. Now what you do, you get these two numbers 1 and 4 and you distribute them in this position. So you have that x squared plus 5x plus 4 is now equal to, let me clear this, is now equal to, I have x squared, and instead of 5x I have 1x. This one will give me this x plus, this is a 4, I have 4x, then plus the 4. So the only difference is that instead of 5x I have these 2. Those 2 are in the place of 5x. X squared plus 5x plus 4. It is still in concordance with this. X squared plus 5x plus 4. But the 5x has been replaced by the factors I got here, 1 and 4. 1 and 4. Now after that, I need to group these expression, to group these terms into, I have x squared plus x in one group, plus I have 4x plus 4 in another, and then I look at each group and I factorize out the common factors. So around here there is x here and there, so I remove x and I remain with x plus 1. Then around here with this, the plus sign is still there, this is that. Then here I have 4 is here and there, so I have 4 into x plus 1. And after that, I have x plus 1 here and there. I write it once. X plus 1 is being factorized out. When x plus 1 is removed from here, I remain with x. Then here I remain with 4. Some people say you get this x plus 4 and then write the bracket once. But what we are doing here is pulling out the value of x plus 1. It is like it is similar to when you have xa plus 4a, and you are pulling out a, remaining with x plus 4. So look at this a as this bracket here, xa minus 4a. Pull out the a, have x plus 4 remaining there. So this one is the factorized version. X squared plus 5x plus 4 is the same as x plus 1 times x plus 4. That's what we have. That is example 1. Still here, the sum is negative 8. I told you the coefficient of x and the product is the value of the coefficient of x is 1. The constant is negative 33. So this is 1 times negative 33, getting us negative 33. And the numbers that can give us those results, we have negative 11 and 3. When you add these two numbers, you get negative 8. When you multiply them, you get negative 33. So we shall have that x squared minus 8x minus 33 is now equal to x squared minus 11x plus 3x minus 33. So what we have is that we have got, instead of having 8x, we have put these two values there. The 11 negative and the 3 positive instead of that 8x. That's what we do. And from there, we shall now have, this one is now x, there is x here and there. Actually, maybe let us say we group them like this, plus this one is 3x minus 33. This grouping is working when we have positive values in the middle there, but if it's negative, things may get bad. But for now they are good. So we have x, and the x is common there. Pull it out, remaining with x minus 11. So that when you open the bracket, you go back to that. Plus, there is a 3 everywhere, x minus 11. Actually, in most cases, the two brackets must be the same. This bracket and that one. So after getting the first bracket, you should know that even the second bracket should be given by that. So after knowing that the second bracket should be x minus 11, then you know that, oh, how do I get 11 there? How do I get x there? Pull out the 3, and there you are. Then I have this x plus that 3 being pulled, being remaining after pulling out x minus 11 to the right. So when I pull out x minus 1, it is common everywhere. Actually, this is what I'm doing. I have x minus 11 pulled out. Then this position here, I remain with x. Then here, for this, I remain with 3. So that is that's what we have. The two are the same. This one and that one are the same. These two, this one and that, it is the same thing. So you can write either this or that. That is because those are the factors of this. You multiply these two to get that. There you are. This one is now 2x squared plus 3x, 2x squared plus 3x plus 1. The sum is 3. The product is 2 times 1, which is equal to 2. And the two numbers that can help us, that are in such a way that sum is 3 and product is 2, they are 1 and 2. So we have that 2x squared plus 3x plus 1 is now equal to 2x squared plus x plus 2x plus 1. 2x plus 1, which is equal to, we now have here and there, and then there. So we have here and there is x, pull it out, remaining with the 2x plus 1. The only factor which is between this and that is 1. So we have 2x plus 1. Then we have 2x plus 1 being pulled out, and then we have x plus 1 remaining inside there. X plus 1, then 2x plus 1 written once. Factorize out 2x plus 1, and then here remaining with x, which is this. Here remaining with the 1, which is that. And that's basically what that you have there. This is basically what you have. This one is 3x squared plus 5x minus 22. Sum is 5. Product is equal to negative 66. And the numbers which are responsible for that, we have 11 and negative 6. When you add those two numbers, you get 5. When you multiply them, their product is negative 66. So we have that 3x squared plus 5x minus 22 is now equal to 3x squared plus 11x minus 6x minus 22. And we are having 11x and then, so we have, that is what we have there. We look at this and that, the only factor which is there is x. So we have x out, then this one is 3x plus 11 minus, the common factor between there is 2. So we have 2 into 3x plus 11. This is plus because when you introduce a bracket here and this is minus 2, this one should be plus such that negative 2 times 11 will get us the negative 22. So don't put here negative. Otherwise, if you put a negative here to match this one, you may think that you are making this one match this minus, but you'll be doing something wrong, because after introducing this bracket and this one is minus and this is minus, this one must be plus, so that when you open the brackets here, you get back to that. If this one was minus, you could have that negative 2 times negative 11, you will get a positive there, which is not actually what you want. So this one is pull out 3x plus 11 into x minus 2, and that is so after having these brackets the same, we write the two brackets once and then x minus 2 in another bracket. In other words, I'm pulling out. It is like you have, I don't want to say things where people just wrote and do some bit of roteland. This is x times a minus 2a. When you have that, you pull out a, remain with x minus 2. So look at that. Look at this bracket, which is the same as some value a. So you pull it out and then remain with the x minus 2. There you are. This is the answer. Part E, we have the sum is equal to 32 and the product is 4 times 15. I told you sum is B, product is AC. Yes, product is B, where B is the coefficient of x and A is the coefficient of x squared and C is the constant. So AC 4 times the 15 there. And now this one is getting us, it will get us 60. And the numbers which can give us that, they are 30 and then 2. So what we are going to do is to say that 4x squared plus 32x plus 15, it is the same as 4x squared plus 30x plus 2x plus 15. So I still insist these two are the 30 and the 2, 30 and 2 in the place of the 32. So you can say that it's still 32, that 30 and then 2. It remains like the way it was. So around here, grouping, we have grouping these two and these two. We now have the LCM, not LCM, man. The common factor, where we have 30 and 4x squared and 30x. The common factor is 2, is 2x. So pull out 2x and remain with 2x here, then plus 15. That's what you have. There is no other way. So there is a 2x here because 4x squared is the same as 2x times 2x. So you have 2x, and here there is an x, as you can see. This one is divisible by 2. So you can replace that 2x is common here and there. Then the one which is common there and there is nothing. It is just a 1. So 2x plus 15. If you want, you can put a 1 there. But mathematically, and now this one is like you have 2x a plus a. What you are going to do is to pull out a and remain with the 2x plus 1. That's what you have. If I say that the bracket here is standing in the place of a, so our final thing there shall be, we shall have this one is now equal to 2x plus 15. That is like this a for these two brackets. The remaining is here 2x plus here remaining is with 1, and the answer is now this one here. That one there is the answer. That one up there. The sum is equal to 4. The product is equal to 16 times negative 2, which is equal to negative. This one is negative 32. The numbers that can give us those two, that when you add them, you get fun. When you multiply them, you get negative 32. We have negative 4 and 8. So we have to distribute this one in the place of the 4. So we have 16x squared plus 4x minus 2 being equal to 16x squared minus 4x plus 8x minus 2. The order you put them there doesn't matter. You shall get the factors. So it does not mean that you should start with this. No, it doesn't matter. So around here we have now disputed. Let me still insist. I'm insisting that these two are occupying the space of 4x. So when you add these two, you get the 4x. And how do we get this? They are the numbers which are satisfying these two conditions. That their sum is 4, their product is negative 32. And now there, we shall not say that we are adding, we are split and we are just grouping them. So we are grouping these two and those two, such that we have 16x squared and then 4x. The common factor there is 4x. 4x is here and there, and here shall remain with 4x, because the 4x times 4x you get 16x squared. Now this is minus 1, having pulled out 4x. 4x times 4 is the one which will give us that. Now plus, around here we have a common factor which is 2, and we still have 4x minus 1. 4x minus 1. And now look at 4x minus 1 as sum a. Then you have that a factorized out. 4x minus 1 into what remains there is 4x plus 2. That is the factorized version of the expression they have given us. Then we have this 9x squared minus 15x. The sum is negative 15, and the product is 9 times negative 14, and this is negative 126, and the numbers which are responsible for that, negative 21, then 6. Actually, there is a method you need to use, because some of them may say, now where are you getting the 21? How are you getting them like that? You can get them from the product. Like this product, negative 26, it has a number of factors. Like it can be by 2, you have 63, and 2. Just look at positive 26 itself. Just look at the 26, because this is I'm illustrating something which is general. So you have 63 and 2. You can have 42 by 3. These are things that can give us 126. And now you see that, for example, let me test with this. Having that the sum is negative, because after getting these two numbers, you need the product is the one you are getting, but now you want to ensure that they satisfy the sum also. By looking at these 63 and 2, there is no way you can sum up them and get 15. You see, there is no way you can sum up and get 15. Then you know those one is out of that one is out. 42 and 3, yes, the product is 126. Even if I put a negative here, I can get negative 26 as it is here, and I multiply. But when I add, no matter which one is negative, by having this one negative, it means that either this is negative or that. But here, even if I put negative there, I cannot get a sum 15. Put negative there, I can't get a sum 15. The same applies to this. When this is negative, yes, I have negative 126, but the sum is not 15, negative 15. When I put a negative here, the product is yes. When this one is positive, now I have a negative there. If this is positive and this is negative, the product is yes, negative 126. But oh gosh, the sum is not 15. Until when I come to 4, 4 is not a factor here, and so is 5. 5 is not a factor. So I move on to 6. Where I have 21 by 6. Then when I check this, I see that when I have negative 21 and then 6, I'm getting negative 15. And negative 15 and then negative 126. If I have 21 and negative 6, yes, I have negative 126, but the sum is a positive 15. So by getting the factors here, you can know now, by distributing the negative now, to know which one is the correct pair. Negative 21, 6, to get us 20, to get us negative 126, and negative 15. 21, because you maybe you could start with this and see, 21 and negative 6, yes, I've got it. The product is negative 126. Let me try to establish the sum. 21 plus negative 60, negative 6. Then you see, you are getting 15, and it's not working. You see, then you also say, that is not working. Let me try to put it there when this is positive. Then you come to the correct thing. So you can look at just by factorizing, looking at the factors, and not just by using maybe the factor tree, but looking at the different numbers. Check with the one. I've left it 126 by 1. You never know. In some other thing, you may have the that product and 1. Then look at 2. 126 divisible by 2. How many times? 63 times 2. Look at 3. Is it divisible there? 43 times 3. Is it divisible by 4? No. Is it divisible by 5? No. Go to 6. 21 by 6. What about by 7 by what? Then you know, they are almost. You can check with all of them until you see you get the pair that can get you what you need. So here we have already got the pair, and we now have that 9x squared minus 15x minus 14 is equal to 9x squared minus 21x plus 6 minus this one is 6x minus 14. And now we group these two. The common factor here is it should be 3x. 3x is common here and there, and we have 3x minus this is 7. Then plus the common factor here and there is 2. And I have 3x still minus 7. And pull out 3x minus 7 because it is common everywhere. Then here remain with 3x, here remain with 2. And I have that as the factorized version of the given expression. Here they want me to simplify that expression. I look at let me first look at the numerator. Let me handle the numerator here. Is 3x squared plus 2x minus 8. And we have that the sum is 2 and the product. Look for two numbers with a sum 2 and the product negative 24. And those numbers by the method just illustrated up. Let me put it here for the purpose of emphasizing. I'm looking at 24. 24 is the same as 24 times 1. It is the same as 12 times 2. It is the same as 8 times 3. It is also the same as 6 times 4. And after that it just repeats. So these are some of the pairs that can give us. If I look at negative 24 and 1, it doesn't give in terms of sum. Then 24 and negative 1, it doesn't give. So that pair is out. Negative 12 and 2 does not give us a sum of 2. Or 12 and negative 2, it still doesn't give us. Now when I talk about this, these are the possibilities and they are not giving us. I look at 8 and 3, negative 83, I don't get a 2. Then 8, negative 3, I don't get it. Then I look at 6 and 4. Negative 6 and 4, I get the sum. All of these pairs are giving me the product, which is negative 24. But the sum itself should also be 2. The sum should be 2. And all of these ones are giving me a sum which is not 2 when I add them. So around here, negative 6 plus 4, that is negative 2. Yet the other one is positive. So I check with 6 here and negative 4. Yes. Product negative 24 and the sum is 4. That is what we do. This one is 6, negative 4. And now I have 3x squared plus 2x minus 8 equaling to 3x squared plus 6x minus 4x minus 8. Grouping these two, the common factor is 3x, and I have around here remaining with x plus 2 minus this is minus 4 into x plus 2. So that this is x plus 2 into 3x minus 4. There I have just got the numerator. And now I write the whole expression. It is 3x squared plus 12. Oh, this is not 12, but this is 2x minus 8 divided by 9x minus 12 is equal to x plus 2 into 3x minus 4 divided by, now this 9, there is a common factor there. There is a 3 which is common everywhere, so I remain with 4x. That one is actually not 4x, but I remain with 3x minus 4. I'm factorizing out the 3 in the denominator. There is a 3, so we are factorizing out the denominator. We are getting that, and now we see that this one and that one, they can cancel each other out. So we have this thing as x plus 2 divided by 3 as the final answer. Part B, now the numerator is okay. Let's first get the denominator here. Let's work out the denominator first. I could just say equal to, then I write things there, but I want to display some brevity. Sum is -4 and the product is equal to -21. With the same method, we look at the values as -7 and 3. These are the numbers which are in such a way that when you add them, you get -4. When you multiply them, you get 21. So we have 3x squared minus 4x minus 7 equal to 3x squared minus, we now have 7x plus 3x, then minus 7. I told you the order doesn't matter. You can start with, provided now these two can give us -4x, which was there. That is what you have there. Now group them. There is an x here and there, so you have x out, remaining with 3x minus 7 plus remaining with 3x minus 7. Pull out 3x minus 7 as if you are having an a, so you have 3x minus 7 here and there. Pull it out, remaining with x and remaining with 1 there. That is the numerator, actually the denominator. And now we can now say that 3, this one is x squared plus 4x. Where am I getting the 4x, man? This one is plus x divided by 3x squared minus 4x minus 7 is now equal to, this one can also be factorized somehow. So I have x out and I have x plus 1 divided by, now the factorized version of this is the one we got here. So we have 3x minus 7 into x plus 1. There is some cancelling going to take place here. This one goes with that, and I finally have that this one is equal to x divided by 3x minus 7. That is what we have there as the final answer. Then, oh man, We have this also. Simplify, guys. They're saying simplify. So look at this and you see that there are two quadratic expressions. The numerator is a quadratic x, is a quadratic expression, and the numerator and denominator, both of them are quadratic expressions. So let us start with the numerator. Let me separate them. Numerator, x squared minus 7x plus 10. The sum is negative 7 and the product is 1 times 10, which is equal to 10. And the numbers which can give us that, we have the number negative, actually the numbers that when you sum them up, you get actually negative 5 and negative 2 can do that magic. This plus that is that, this times that is 10. Yeah, so we can say that this is now x squared minus 7x plus 10 can be written as x squared minus 5x minus 2x plus 10, such that now the common factor here and there is x, pull out x into x minus 5, then minus 2 into x minus 5. After getting the first bracket, don't be hard on yourself. The second bracket must also be the same as the first one. So just by establishing the factor there, it comes to the same thing. So x, this is minus. Somebody will say, no, yes, for this is minus and minus, the one which will give us that plus. I told you avoid saying that you are considering consistency of the symbols there. Once this one is a negative here, you need to be careful. So this is x minus 5 into x minus 2. That is the numerator. Then the denominator, is 2x squared minus x minus 6 with a sum which is negative 1. The sum is the coefficient of x, and if it's just negative x, that is the coefficient is negative 1, and the product is 2 times negative 6, which is equal to negative 12, and the factors there that can give us that negative 4 and then 3. Those are the numbers that are in such a way that their sum is negative 1 and their product is negative 12. And now from there, we work out 2x squared minus x minus 6 is equal to 2x squared minus 4x plus 3x minus 6, which will get us, now there is a common factor here and there, which is 2x. So there is a common factor 2x everywhere, 2x. When I factorize out 2x here, I remain with x there, and here I remain with just 2. Then plus, there is this, and then x minus 2. So that this one is now x minus 2, and this one is 2x plus 3. That is now the denominator. And now I can write the whole thing. X squared minus 7x plus 10 divided by 2x squared minus x minus 6 is now equal to, I'm now going to write the factorized version is x minus 5 into x minus 2. That is the numerator. This one, we factorized it to this. And then down here, we have just got it as x minus 2 into 2x plus 3. And we now see there will be some cancelling. There is this one goes with that, and when those ones go, I remain with the I think you are peeping at solutions of quadratic equations. We shall look at that in the next video. Just keep around. Subscribe.